Hey folks, this is Mr. Hartzler, and today I'm going to talk to you about using the area formulas to derive the law of sines. So let's get started on that, and to do that I need to start off with the law of sines, the areas of those all written out. So in the last video I talked about, that 1/2 BC sine A equals 1/2 AC sine B equals 1/2 AB sine C. So if you notice here, all of the letters are represented every single time, and whatever my two sides are, the angle is the other letter. Alright, first thing I'm going to do is get rid of all my 1/2s. Those are kind of bothersome, kind of in the way, so I'm going to multiply everything by 2. Again, all three of these are equal to each other, so as long as I do something to all three of them, everything is still equivalent. So those 2's and 1/2s are all going to cancel now. BC sine angle A, side AC times sine of angle B is going to equal AB sine C. Now the law of sines looks a little bit different than this, so I'm going to divide everything here by A, B, C. When I do that, you'll see that a lot of things can cancel. This B and this B cancel, this C and this C cancel, and over here I still have stuff canceling, and same thing on the last round. Now if I write down on the next line everything that's left, I have sine of my angle A divided by side A equals sine of angle B over side length B equals sine of angle C over side length C. So hard to tell with C's, but that's a capital C, that's lowercase. Alright, that is law of sines, and that is something you should really remember. The nice thing about this is it works for non-right angles, or right triangles. The reason we use SOHCAHTOA so much earlier in the year is because SOHCAHTOA works for right triangles. But now we're getting to some fancy triangles, so we need fancy laws to be able to help us use and solve for the rest of the things in those triangles. So again, we have all of this. Pretty easy to remember: A over A, B over B, C over C. And the exciting thing is, as long as you flipped everything here, or did the reciprocal of all of these, it still holds true. A over sine A, B over sine B, C over sine B. Alright, so let's go over here now and do an example. So I have this new fancy little triangle, and I need to solve for all the missing pieces. First thing you should notice, I have 2 of my angles. So to find that third one, pretty easy. All the angles must add up to 180. So I know 80 degrees plus 45 degrees plus angle A must add up to be 180. So I subtract all of those things. That's 125. So 55 degrees equals angle A. I'm going to write that in there. Now I need to find my missing side, B and A. So I'm going to set up all my little ratios first. Let's see if I can squeeze this over here. Alright, there's a little bit more space. So I know that sine of angle A over A, sine B over B, and then sine C over C. But what's more important here is all the stuff I know. Let's plug those things in. I know my angle A. Now I actually know all the angles. So I know sine of 55 is over the side length A. Well, I don't know that one yet. I know my angle B is 45. Side length B, don't know that one either. And that equals sine of C, so that's 80 degrees, over side length C, and I do know that one. So I have 2 incomplete ratios. I don't know A and I don't know B, but I have one completed ratio. I'm going to use this one and one of the other ones to solve for each of the missing pieces. So let's do these 2 first. Sine 80 over 3 equals sine 55 over A. I don't like A in my denominator, so I'm going to multiply by it. So A times sine 80 over 3 equals sine 55. I'm dividing by 3, so I'm going to multiply by 3. Now it's canceled out. I have a times sine 80 degrees equals, I'm going to move that 3 out front. I'm allowed to move that 3 in front. That's the commutative property of multiplication. And now I have to divide by sine 80. So a equals 3 times sine 55 over sine 80. And this is the point where you pull out your handy dandy calculator and you plug all of that nice information in. And we end up with, let's see here, not 7, 3 times sine 55 divided by sine of 80. And I'm missing my parenthesis in there. Way back here. And we end up with 2.495. That's side length A. Now I still need to go in and find B. Let's go over to another page for that one. I always want to use the information they provided me with instead of my own answers. So this was all the information they showed me. I definitely want to use that. The good thing is, if you use their numbers, you're less likely to be wrong. If I use the numbers I got in that last equation I did, well, maybe I would have made a mistake in there, and maybe I screwed something up. If I'm using their numbers, I'm less likely to have mistakes, or at least my rounding mistakes are going to be less significant because I'm using their initial numbers. So the ratios I'm using here are sine 80 over 3 and sine 45 over b. That came from the initial ones we were setting up here. I need to solve for b, so I'm going to multiply by b here. So now I have b times sine 80 over 3 equals sine 45. I'm going to keep that b a little bit separate. It's still being multiplied, but now it's a little bit easier to see that I can get rid of both of these things at the same time. I'm going to multiply by the reciprocal. 3 over sine 80 times 3 over sine of 80 degrees. B equals now sine 45 times 3 over sine of 80. We plug all of that magical stuff in. Sine 45, which should be a memorized value for you, times 3 divided by sine of 80. So if you're one of my students, what's the memorized value for sine 45? Square root of 2 over 2. I keep forgetting my calculator doesn't round for me unless I tell it to. Alright, so B is 2.154. That's my last side, and I can plug that in over here. Equals 2.154. I was able to find all the pieces to my triangle, and I did it using law of sines. So I hope that was helpful for you, and if you have any questions, please leave them down in the comments. If you're one of my students, please send me an email, and I'll get back to you as soon as I can. If you want to like and subscribe, I would love that. If you want to follow me on Instagram and Twitter, that's not a bad idea either. My Twitter is Mr. Hartzler, Mr. Hartzler Math, and my Instagram is Mr. Hartzler. Please like and subscribe if you like what I see, or like what you see, and hopefully I can get some more content up if you let me know what you're interested in seeing. Have a great day, everybody, and make sure you continue on with carefully and with enthusiasm.